Problems packet, page 1. Is everybody ready? Okay. Page 1, 1, 2, and 3. 1 is B, 100. 2 is F, 11. G, 3 is G, $92.50. Okay, are we ready for the next page? Okay, 4, 5, and 6. 4 is K, 244. H is 5, which is 20. And 6 is H, 36. All right, if we're ready, we'll keep moving. Number 7, let me kind of scroll down here so that as far as video-wise we can see what's going on. 7 is C, 12, 24, 24.
Not change the attendance that comes up for your hour on SIS. That attendance is actually for Friday. Please just email all attendance to Sandy today so that she can keep a record until our calendar is updated. Thank you.
Okay. Let's see. Number 8 is H, 46. And then area of polygons. Area of polygons. Number 1 is E, 2 to 7, or 2:7, or 2/7. There's a lot of different ways that you can make that ratio or scale factor. Number 2 is G, 225. 3 is B, 100. 4 is D, 13. 5 is H, A, radical 3. Okay, 6 is G, 30. 7 is B, 18. 8 is B, 96. 9 is K, 41. 10 is J, 2 to the 9th. 11 is C, 72. 12 is G, 60. Do I need to go back to any at this point? We're good. What's that? 8. 8 was B, 96. All right, where did I leave off at? 12. Okay, so we're ready for 13. 13 is C, 4. 14 is B, 8. 15 is E, 90.0. 16 is, D, 83. 17 is J, 50. 18 is F, 20%. Do I need to go back to any at this point? No? Okay. 19 is D, 5/9. Okay. Now Pythagorean theorem. I think that you'll notice that this question is a repeat. Number 1 should be H, 46. If you got it right the first time, you probably got it right here. If you got it wrong the first time, you might have gotten it wrong here. Number 2 is C, 13. Number 3 is D, 4.8. Number 4 is B, radical 29, or square root of 29. 5 is H, 13. Okay, 6 is D, 24. 7 is J, 2 radical 3. 8 is B, X minus 2 squared plus y minus 3 squared equals 25. 9 is, k 4 radical 5. 10 is k 41. 11 is j 25. 12 is j 10 radical 3. 13 is 9 plus 3 radical 5. 14 is 16 thirds times radical 3. C. 15 is C 500. 16 is B, the square root of 50 minus 20 squared plus 25 minus 40 squared. C, that's B. 17 is F 13. Okay, we're getting close anyway. 18 is E 10 radical 2. I believe 19 is a repeat. Is 5/9 D. And your last question here, number 20, should be H 3.6. H 3.6. All right, we're going to go back up and we're going to cover as many questions as we can in terms of answering the ones that you might have gotten wrong. Okay. Anybody on the first page, 1, 2, or 3? Go ahead. 2. 2. 2. Okay. Let's see. Let me try to stir this up here a little bit. Okay. A standard sheet of paper. Okay. Now this one's going to be kind of tough to show on the board. So I may have to show both groups. All right. Standard sheet of paper is 8.5 by 11, okay? Or it's 8.5 across here by 11 longwise, right? It's rolled up so that the two shorter edges just meet. So my two short edges are going to be here and here. If I roll it so that these just meet, okay, you follow me? Okay. Forming a circular tube that is 8.5 inches high. How many inches is the circumference of the tube? Okay, hold on a second. All right, watch this. Now, you would agree that that's the circumference, right? Watch this. Do you get it yet? No. Okay, all right, watch. See this length is 11? What's the circumference? There you go. It's 11. All right. Because the length of the paper becomes the circumference of the circle. All right. Let's see. Did anybody need 1 or 3? 3. Okay, a rectangular garden is 10 feet wide, 15 feet long. If fencing costs $1.85 per linear foot, how much would it cost for exactly enough fence to enclose the garden? Okay, so this is perimeter, right? So 10, 10, 15, 15. So you're at what, 20 and 30? So we'd have 50 feet. So 50 times 1.85, right? And I could pull out a calculator here, I guess same as you. 50 times 1.85 should come out to $92.50. Okay. What did you do on that question? You did the area. Yeah, well, fencing should always be a perimeter question. They do a lot with fencing. Okay, let's move on to the next page. Number 4 usually gets asked. 4. Okay. Again, these are a lot of questions that we tend to make more complicated than they need to be. Okay. 2 strips of tape are to be used to wrap a box as shown below. Both strips must go completely around the box. What's the minimum length of tape in centimeters required to wrap the box? Well, the minimum length is just going to be where the ends will meet, right? So we're talking about perimeter both ways. Okay, so if you really want to think about this, here's 30, okay, and there's 26, right? So then it's going to come across another 30, and it's going to go up another 26, right? So I'm going to get 60 plus, 52? It's going to be that length of tape, so it should be what? 50 and 60 is 110. 110 plus 2, so 112, is that correct? All right, and then we're going to do the other direction. So there is 40, and it's going to go down 26, 40. So I should get 80 plus 52, is that right?
Oh, okay.
Okay,
So where's the 52 from?
26 and 26.
26 and 30.
No,
Oh, yeah, okay.
because the height is still the height, right? So 80 and 52 should be what, 132? 132. So I add those up, and I'm going to get, should be 244. 244. Okay, this is perimeter plus perimeter. Are we making that more difficult than it needed to be? That was my guess. All right, what about 5 or 6? Yeah, hey, 6. All right. Here what we're going to end up doing is we're going to take that height line of QP and we're going to move it over. So we're actually using it here and here because it's still going to be 4 in those places. Right? If this length across here, because it says what is the perimeter of the trapezoid, so I need to know what is this length right here. That's what I've got to find, right? Okay, so in order to do that, what I actually need to solve for is what is this length here and here, if this is 4. Well, what's handy about this is that if I know my Pythagorean triples, right, and these are forming right triangles, okay, that I know that I'm going to have a what type of triangle? A 3, 4, 5 right triangle. Now you could use the Pythagorean theorem and do 4 squared plus b squared equals 5 squared because we know that 5 is our hypotenuse. All right, and just take 16 minus 25, and that's going to give me 9. I'm going to square root 9. I'm going to get 3. So what we're seeing here is that this length right here is 3, and that there is 3. 3 and 3 is 6. We're going to take 6 from that total length of 16. So we see that this length right here is 10. Does that help? All right. Now I'm just adding up my total length. So I'm going to have 16 plus 5 plus 10 plus 5. So 16 plus 5 is 21. 21 plus 10 is 31. 31 plus 5 is 36. Okay, and that's going to give me my perimeter. Okay? All right. I know I'm kind of maybe flying through some of these a little bit, but it's a big packet, so I'm going to try to do this as quickly as I can. Number 7 and 8. Ryan? 7? 7? Are you needing 8? Okay, so just both of them. The perimeter of a parallelogram, 72 inches. One side measures 12 inches. What are the lengths in inches of the other 3 sides? Well, what we have to remember about a parallelogram, and this is a geometry concept, that we have 4 rules for a parallelogram, and this will be in the audio, so you can write these down later, but the important one here is the opposite sides of a parallelogram are congruent. Opposite angles are congruent. Diagonals bisect each other, and consecutive angles are supplementary. Okay, so I know that these two are going to be congruent. I know that these two are going to be congruent because it's a parallelogram. So if one side measures 12 inches, then I know that this side over here measures 12 inches. If I know that the total perimeter is 72, what I'm going to do is take 72 minus 24. Right? Somebody tell me what that is real quick. 48. And because these two sides are congruent, they have to share that 28. So we need to take 48 and divide by 2. We're going to get 24. So the other three sides are 12, 24, and 24. Okay? Does that make a little bit more sense? That's where that geometry stuff comes in kind of handy, is knowing the rules for parallelograms. So I'd go back and listen to this part of the audio and write those 4 rules down. Okay? All right, number 8. All right, Theo, it shouldn't be Theo, it should be the polygon below was a square with 12-inch side lengths before a triangle was cut off. What is the perimeter in inches of this polygon? What's really hard to see here, you may not have been able to see it in yours, is that there are some links in here mentioned. It says that this is 12, this is 8, this is 9. Were you able to see that at all?
I didn't see that. What I did is I did 3 for the short side on top, and then
Sure.
4 for the long side on top.
Yeah, you're right. So that's good. So you said 3 and 4. So hopefully we knew that that length was
5.
5.
And then I added them all together. 9, 5, 8, 12, 12, and then I got 46.
All right, because this length should be 12 here, right?
Yeah.
Yeah, 46 was the answer.
But you said
8, 46.
okay.
Yeah, if I had said something along the lines of 20, I would have been way off because there's not even an option for that. So yeah, it is 12 plus 12 plus 8 plus 5 plus 9, right, is how you want to find that. Yep. Okay, well, it's still, somebody might have needed it, and now we've got it, so. All right, area of polygons. Let's see, we got 1 or 2 on this one.
No.
No? Anybody 1 or 2? Nobody 1 or 2?
2 actually.
2. Okay, good. In the figure below, a square is circumscribed about a circle with a 30-inch diameter. Points A, B, C, and D are the midpoints of the square sides. What is the total area in square inches of the shaded regions? All right. What's interesting about this is that this shaded region could just as easily be here, right? So let's just put it there. Let's make our life easier. So really what that shaded region is it's 1/4 of the whole circle, right? All right, so if it's a 30-inch diameter, right, then that means that the side lengths are 30, right, because it's a square. Right, yeah. So what we want to find is we want to find the total area of the square and divide by 4. So it really should be 30 times 30 divided by 4, right? So 900 divided by 4. What's that come out to? 225. Okay, so that was made to be a lot more difficult than it needed to be. But when they give me something like that, there is a much more complicated way to do it. In fact, I've got the work for the really complicated way to do it, but being able to be successful on the ACT is finding easier ways to do it, looking at it, making your life more simple. Okay?
What I did is I found the area of the entire square.
Uh-huh.
And then I divided it by 4 because there's 1/4 of the circle. I found the area of the
Circle and divided it by 4, and that would have given you this right there.
And I found the area that's like 1/4 of the square, and then subtracted.
The circle. Well, yeah. Okay. So what I had in here is that, yeah, I did the same thing. I took the area of the circle and then divided it by 4 to get that red portion there, which is comes out to like 176.7. And then I took I subtracted that from the total area of the square, right? And then divided that by 4 to find this, right? And then added those two areas together. But that's way more work than what's necessary here, right? So that's the difference in time is probably about a minute or two, right? Maybe more than that if you're struggling to try to remember your formulas. So yeah, the area of the square divided by 4 is going to get that answer much, much quicker. All right, number 3 through 5, I'm guessing maybe 4. 4, yeah, 4. Okay, the area of a trapezoid below is 16 square inches. The altitude is 2. The length of one base is 3. What is the length of B of the other base in inches? So if they tell me the area, I'm going to set, okay, it's 16. Now what I want is I'm going to set that equal to the area formula of a trapezoid, which is base 1 plus base 2, right? Times height divided by 2. So if I have an unknown base plus 3 times a height of 2 divided by 2, right, that's going to help me solve for B because I already know what the area is, okay? Well, the 2 divided by 2, that should cancel itself out, correct? Okay, so that cancels it out. So what I get is 16 equals B plus 3, all right? So subtract 3 from the other side, or from both sides. So I should get 13 equals B. What I would do before I moved on, because that's relatively quick to solve that, okay, and my answer is this, is that I want to go ahead and plug that back in, all right, and see if I get 16. What's 13 plus 3? 16. 16 times 2 is 32. 32 divided by 2 is 16. That equals my area, right? So 13 does work for the length of the other base. Does that help? Okay. Anytime they give me the answer, you know, they say the area is this or the volume is this, and they give me a number, put that on the other side of your formula, and then they may give you the volume of a sphere, and then ask you what the radius of the sphere is, right? So you put that answer on one side and set it equal to your formula and any other information they give you, and then just solve for that variable. All right, numbers 3 or 5?
5.
5. Okay. If the rectangle on the right, if the rectangle and the right triangle in the figure below have the same area, so I'm going to be able to set those equal to each other, and indicated lengths are given in inches, what is x expressed in terms of A? All right, so I'm going to set their areas equal to each other. The area of a rectangle is length times width, correct?
Yeah.
All right, so 3A times A has got to be equal to base times height divided by 2. So that's 2x times x divided by 2. Let's go ahead and simplify both of these. What's 3a times a? 3a squared equals, what's 2x times x? 2x squared divided by 2. Will that simplify at all? 2x squared divided by 2 is just going to be what? X squared. So what I can say is that this is equal to just x squared. All right, and if I want to solve this, what is x expressed in terms of a? Then I'm going to square root both sides, okay, to get just x. All right, so x equals, and because that's a squared, that means I can take an a out of that square root, but I can't take a 3 because a is a prime. 3 is a prime, so I get a radical 3. Does that make a little bit more sense now? Okay. Okay, and again, if we wanted to see if this was correct, we could plug a radical 3 in for x in our triangle and see if it comes out to 3a squared. And it should. And we would do that if we had a little bit more time. Okay, our next page is 5 and 7. I'm sorry, I said 5 and 7, 6 and 7. 6? Okay. What is the area in square inches of the figure shown below? The first thing we need to identify is that this is a trapezoid. All right, formula of a trapezoid is base 1 plus base 2 times the height divided by 2. All right, so base 1 and base 2 are 8 and 12. The height is that length right there. Okay, so that's 3 divided by 2. Okay, so 8 plus 12 is 20. 20 times 3 is 60. 60 divided by 2 is 30. Your answer should be G, 30. Okay, so I would probably go through somewhere and I would write down the area formula of a trapezoid. Right, and you should know that, hopefully. Okay, anybody on 7? Nobody on 7? 8? Yeah, 8. Good. In a triangle below, angle AED and BCD each measure 135 degrees. But DF is an altitude of triangle CDE and BCDE is a rectangle. What is the area in square meters of the pentagon? All right. So if AED is 135 and this shape right here is a rectangle, what I'm finding out is if that's 90 degrees, then the number of degrees left out of 135 is actually 45 degrees, right? So that means this is 45. They told me that this is perpendicular, is an altitude, which means it's perpendicular. So what I have is two 45, 90 right triangles. Okay, so we actually have a special right triangles that we can work with here, and because we're in Algebra 3, we should already know our 45, 90s, right? Okay, all right, we know we've got 10, we know that this has a height of 4. All right, let's use a different color here. That's 4, so that means this is 4, right? Okay, what we're really trying to find here is this length, so if this is 4 here and this is 4 here, then it should be 4, 4, 4 radical 2, correct? Okay. Okay, and it says what is the area in square meters of the pentagon? So what we're doing is we're adding two areas together. We actually don't even, now that I think back at this, we really don't need that because we're just trying to find, more than that, we needed to know that this was 8. Okay? We didn't really need the 4 radical 2 because we're taking the area of the triangle plus the area of the rectangle, but we needed the 8 because we need to take 10 times 8 to get the area of the rectangle to be 80. And then on the triangle, we needed base, which is 8, base times height, which we already knew was 4, and divide that by 2. Okay, 8 times 4 is 32. 32 divided by 2 is 16, right? So 16, we're going to add these together, we should get 96. Okay, so like I said, the 4 radical 2 wasn't really necessary, but that's an easy way to get distracted, because if they were asking for perimeter of this, we would have absolutely needed the 4 radical 2, because we would have taken the 10 plus the 8 plus the 10 plus the 4 radical 2 plus the 4 radical 2, and put all that together for perimeter. So it's not a bad thing to know, but make sure that you're answering the question that's asked, because if you'll notice, they have a perimeter answer in there with 28 plus 8 radical 2. All right, number 9. We got 9 and 10 here. 9. Okay, below in right triangle, ABC, AB is 4 inches. They give you the other part. BC is 5 inches. What is the area in square inches of square ACDE? Here, Let's see. Pythagorean theorem, right?
I see where I messed up. I got radical 41. Well, I got 4 radical 41, but I forgot whenever you multiply radicals by radicals, it cancels the radical.
Well, we should get just radical 41, right? Because it's going to be 4 squared plus 5 squared, so 16 plus 25 is 41.
Oh, I thought, yeah, we should just get one.
We should just get square root of 41 for that length, and they tell me that it's a square.
Oh, okay. So
All right. So because of that, that means that this is radical 41, and what's radical 41 times radical 41? Just 41.
okay, see, that's where I messed up. I was thinking for some reason because it was a radical. It's not going to be a
Okay. All right. Number 10. Nobody on 10? 10. Yeah, this is a common question. Notice that this is 2 to a power. So in a certain cube, each side of a certain cube is a square with an area of 64 square inches. What is the volume of the cube in cubic inches? So what we're saying here is that if each side of a square has an area of 64, it's a square, so we're going to take the square root of 64, which is 8, right? So this is 8 by 8, but it's a cube, right? So we're saying that the height is also 8, or sorry, the depth. We're saying that the depth is 8. All right, so we need to find the volume of the cube. So it's 8 times 8 times 8, which for sake of time is 512. Okay, and we need to break that down. And you notice that it's done in powers of 2. So we're actually going to keep dividing it by 2. Okay, so 512 divided by 2 is 256. Divided by 2 is 128. Divided by 2 is 64. Divided by 2 is 32. Divided by 2 is 16. Divided by 2 is 8. Divided by 2 is 4. Divided by 2 is 2. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 2 to the power of 9. Okay? All right. All right. 11. Okay. 11. Okay, the following sketch shows a living room wall from the front. What is the area of the surface, or of the front surface of this wall in square feet? Again, to me, it looks like it should be a trapezoid because I got 2 parallel sides and 2 non-parallel sides. So we're going to take base 1 plus base 2, which is the parallel sides. So in this case, it's 10 plus 8 times the height, which in this case is 8, divided by 2. 10 plus 8 is 18. What's 18 times 8? Divided by 2 should be 72. 72. So it's just the area of a trapezoid. Notice how many times we've had to use area of a trapezoid formula? Okay, that's one you need to know. Okay, what about 12? 12. In the figure below, we've got C and D are right angles. What's the total area of the pentagon? What I did here is I made a line across so that we could find that. We know that we're going to get this guy right here where that's a right angle. If this is 6, then this is 3, right? Which means the height of that triangle has got to be 4 because we know that we have 3/4, Pythagorean triples. Okay? So now I'm just adding things up. So 6 times 8 is 48 plus base times height, which in this case is still 6, right? The base of the triangle is still 6 times 4. 6 times 4 is 24 divided by 2, 12. 48 plus 12, okay, should be what? 60? 60. Okay, so that's just area of a composite figure. Break it into 2 shapes that you can easily find the area of. Don't forget your Pythagorean triples. right? Or you're just your Pythagorean theorem if you don't remember that, okay? All right. 13 and 14. Yep. 13. A certain rectangle is 3 times as long as it is wide. So let's make that. Suppose the length and width are both doubled. Okay. Here, what I did with this is that I actually picked out some numbers. So let's say this was 1, then that would be 3, right? Okay. Suppose the length and width are both doubled. The area of the second rectangle is how many times as large as the first? All right, well, if I double that, then this is 2 and this is 6, right? So the area of this is 3. The area of this is 12. How much bigger is 12 than 3? How many times bigger? 4 times. Okay, so pick numbers that are easy to work with. Okay, but also fit the parameters of the question. Oh, goodness, what did I do? Oh, gosh. All right. Number 14. Anybody on 14?
Yeah.
14. In the parallelogram, below the lengths are given in centimeters. What's the area of the parallelogram? Parallelogram is just length times width, essentially. Okay? But the length is going to be, it's more like altitude. So that's why we're going to use that 4 instead of that radical 17. So it's just 2 times 4. 2 times 4 is 8. Okay? Because the way this works, okay, like that, where I would slide that over, okay, so if it essentially is going to end up forming a rectangle. Okay, so that's why it uses the same formula. Because a rectangle is still a parallelogram, that it uses that same formula. Okay, 15. 15. Okay, what's the area of triangle ABC in square units? Here I'm finding length. The length from x to x is 6. And then the altitude is going from -9 to 6. So from here to here is 9, and from there to there is 6. So my altitude is 15. So I'm taking 6 times 15. And 6 times 15 is 90, because it's still an area of a parallelogram. Okay? And I'm wondering if they tell you that. Yeah, they do tell you it's a parallelogram. So I don't have to find slope to figure that out. They tell me that. So I'm just finding the lengths. But make sure you're finding altitude. Okay? 16, 17 or 18, which one? 17. Okay? Parallelogram. What is the area? Okay, so again, the altitude is 5, right? The length is 10. Let's see. Why is that different than what I've got? Oh, yeah, nope, that's right, 50. Okay? So just don't use the 8. I'm guessing that you got 80 instead. Yeah, with a parallelogram, it's the altitude. 18 or 16. Yep. 18. The length of one side of a square is increased by 25%, so it's increased by 1/4. So I'm actually dividing it by 4. Okay? So by what percent would the length of the adjacent side have to be decreased so that the area of the new figure, which will be rectangular, is the same as the area of the original square? So what's kind of complicated here, all right, let's do this like this. Because we're working with percentages, let's keep our numbers at 100. So let's say that that's my original square is 100 by 100, right? So if the length of one side of a square is increased by 25%, all right, what I'm going to get is, let's say we do that to this side here, that's going to become 125, right? Because 25 is 1/4 of 100. All right, so that's going to be 125. 100 times 100 is 10,000, right? If I want it to be the same area, what I have to do, it's 10,000. So I'm going to say 10,000 equals x times 125. So I need to take 10,000 divided by 125. 10,000 divided by 125 is 80. Okay, so 80% of 100 is going to be a decrease of 20%, right? If I'm going from 100 down to 80, so it's a decrease of 20%. Does that make sense? Okay, so whenever they give you something like that, it's easier to use 100 because you're converting percentages to numbers that you're used to working with easily. All right, I think I'm down to like 2 questions, 19 and 20. 19 or 20? 19. Okay, in the figure below, ABCD is a square, so we know that's a square. So if we've got x and 2x, let's see if each of these lengths has twice as long as the other leg. What fraction of the area of square ABCD is shaded? Okay, so 1 squared plus 2 squared, because we know that 2x is twice of x, all right, equals c squared. So let's do that. 1 squared plus 2 squared equals c squared. We got 1 plus 4 equals c squared, so square root of 5. So, it's square root of 5, essentially x. All right, I may just have to stop there. If you need, what's this? Oh man, we're a long way from it. Okay, so we'll stop right there. If you guys don't turn this in, but as soon as I get the other half of this done with the other class, right, watch it, go through and fix your questions, and then turn it in at the end of the class tomorrow. Chances are we won't have an assignment tomorrow. You guys will just be finishing up, grading, and doing all of that so we can get caught up, okay?
So we have an assignment tonight?
You do have an assignment.